Today we want to continue with our 2023 paper, second paper, because we finished the second paper first part. So today we want to move on to the second paper, second part. We will start with question number 5. I have asked you to do the questions, okay? Because this is the latest paper, so therefore these are the latest papers. So therefore you need to be very careful, very serious about these papers because your paper will be pretty much similar to 2023-24 papers. Okay. Right. So let's do the question number 5. I hope you have attempted this. Right. A circuit with 3 inputs and 1 output. Uh, a circuit with 3 inputs and 1 output is to be designed. The output should be equal to 1 when the binary value combination of the 3 input is either 1, 3, or 6. So that means when it is 1, 3, or 6, Z must be 1. Okay. Uh, Output should be 0 for other cases. Draw the complete truth table for the above circuit. That is part number 1. So that is very easy. So you can use the exact letters, okay. A, B, C, and Z. So possibility 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 110 and 111. And when the binary value combination of the 3 input is 1, 3, or 6, output is 1. So 1 is this. This is 3. And 6 is 1, 2, 1, 2, 4. 4 and 2 is 6. This is 6. Right. So this is 6. Okay. So this is 1. This is 3 in base 10. This is 6 in base 10. 1, 2 plus 4 is 6. This 1 plus 2 is 3. So in other cases, it must be 0. It must be 0. So that is the answer for the first one. That is 3 marks. Okay. And so let's double check the answers also parallelly. We'll do it quickly because this question looks pretty simple question. Okay. And if you have any questions, you need to ask because I will do it fast. Right. So the truth table, yes. This is 1, this is 3, and this is 6. Right. Correct. So let's move to the second part. B, second. Complete the Carnot map relevant to the above circuit. If you have any question, you need to ask. Above circuit according to the following format. Right? Following format. So they have given you the Carnot map also. 0, 1, 0, 0, 0, 1, 1, 1. Remember, when you go from one to the other, only one value must be changed. Right? Only one value change. Only one value change. Yes, correct. So now let's put it 0, 0, 1. AB is 0, 0, C is 1. AB is 0, 0, C is 1. That is 1. Then AB is 0, 1. Right? AB is 0, 1. And C is 1. AB is 0, 1. C is 1 is this. Then AB is 1, 1. That is this one. And C is 0. That is this. So therefore others are 0. Okay. Right. So that is the Carnot map. Okay. So that is the answer for the second one. Yes, these two are 1. This is 1. Right. This correct. Right. Third part. Using the Carnot map, derive the most simplified product of sum. So most of the time we used to do sum of product, right? But this time examiner has asked product or sum, right? So pay attention to the question. So what you need is not SOP, POS. First, that means you need to mark regions of zeros because SOP mark regions of ones. POS mark regions of zeros, right? Mark regions of zeros. So we'll mark zeros. So you need to mark the biggest possible. The size must be 1, 2, 4, 8, and so on, 2 to the powers, 2 to the power 0, 2 to the power 1, and make sure it's rectangular square shapes. And also you can consider that leftmost row column is next to the rightmost column. Topmost row is next to the bottommost row. In this case, of course, it doesn't matter because they are anyway consecutive. Right. So what are the biggest you can mark? Obviously, this is you don't have any size 4, right? Obviously, no size 6 because we have only 5 zeros. No size 6, so therefore, sorry, no size 4s, rectangular uh, square. So therefore, we have no other option but to go for these two, then these two, and obviously, remember you can have overlapping. Overlapping is preferred because overlapping make is bigger. So you need to mark the biggest possible, right? We did it in the class. You can go through the recordings. So we have 3 regions now. So let's get the expression now. So we'll take this one. So this is basically ABC 0, 0, 0. 0, 0, 0. This is 0, 1. Remember ABC, right? 0, 1 ABC. 0, 1, 0. So which one is not changed? The zeros are not changed. The zeros are not changed because we are writing uh, product of sum. Now zeros are as it is. Ones are bar. Okay. So remember this is POS. So therefore zeros are as it is. This is A plus C. B has changed. B has changed. So what about this? A, B, C. This one is 1, 0, 0. This one is 1, 0, 1, ABC. And this is not change. This is not change. But this is 1, so therefore it must be bar. And this is 0, it must be taken as it is. And now we are into the final one. A, B, C, this region. 1, 1, 1. And this one is 1, 0, 1. So these ones are not changed, these ones are not changed. 1 means bar, A bar plus C bar. So therefore your final answer is A plus C, right? A plus C, A plus C dot A bar plus C bar dot A bar plus B. Of course, these terms can be swapped. Okay. And this also A plus C can be written as C plus A. And also remember A dot B is same as B dot A. But these 3 sums must be there and those sums must be product in whatever the order. Right. So let's see the marking scheme answer. If you have any question, you need to ask. Right. So 3 regions. So the examiner has taken this one and this one. So that is why the alternative answer. You can see either you draw this and this, or you draw this and this. Two are two possible answers. You don't need to write the both. You just need to come up with one. So this is the other one. Okay. So actually, I took this approach. For this approach, what is the answer? Right. A plus C, A bar plus C bar. Right. A plus C, A bar plus C bar, then A bar plus B. Right. A bar plus B. So examiner has taken it as dash. That is fine. We just use it bar. So we got this answer. So therefore, we should get the full marks. Right. You don't need more. Right. And look at the marking scheme. So examiner has given marks for both. Right. Any approach. Okay. Uh, what else? Right. Groupings must be shown. 1.5 marks for the 3 loops, that is marking in the truth table, you get 1.5. Then other 0.5 mark is for writing the statement. Okay. For component B, the term ZD is not compulsory. Okay, it says if you don't specify this as ZD equal, still give marks. That means if you have just given like this, still give marks. Actually, I give like that. Okay. Yeah, I just wrote it like that, but Ideally, you should have written it like Z equal. Okay. But anyway, examiner says if you have forgotten to this Z equal, give marks. Anyway, I also forgot that. But better you write Z equal. Okay. So when you go to the exam, make sure you earn every mark. Right. You can see Z is not compulsory. Uh, right. So that's it. Right. So let's go into the next part. Draw a logic circuit for the simplified expression denoted in 3. That means if you have made a mistake here, definitely you don't get marks for both one because then you draw wrong circuit. Right? Assuming that you have got the correct circuit uh, by only using no gates. You can see by only using no gates, assuming that the complemented inputs A bar, B bar, C bar are also available. That means you can have A bar, B bar, C bar. Okay. But you can use only no gates. So that is tricky. Okay, that is tricky. So usually they ask us to draw only using NAND gates. You can see the examiner has made this question. Actually, this paper is difficult paper. This time examiner says use only no gates. Right? Usually they say use only NAND gates. Right. So let's take this to a uh, not one note because we need to simplify this. Okay. Right. So the expression we got. Right, expression we got is A plus C, A plus C, then we have A bar plus B, A bar plus B. Then another one is, I just took the easier one to the middle, A bar plus C bar, right? A bar plus C bar. Right, so now we need only no gates. No gates. Uh, now this is anyway difficult question. And now they ask you to draw the circuit also, right? So that is very difficult part. Okay. I thought just they ask how many no gates are required. Okay. Uh, right. Simplified expression for 3 by using draw logic circuit. Using no gates, uh, assuming that the complement inputs A bar, B bar, C bar are also available. That means these inputs are available. Right. So that means you have the A bar input. Okay. That means you have the ABC as well as A bar, B bar, C bar. Okay. Anyway, A bar, B bar, C bar you can create using no gates as well. Okay. Right. So now let's see. Um, that is my one. Right. So when we have AND gates, you need more NOR gates. So therefore, I don't like AND gates. Remember the same thing when they ask us to use only NAND gates, I don't like OR gates. But when they ask us to draw using NOR gates, I don't like AND gates because AND gates need more NOR gates, right? So therefore, I will apply bar rule so that I can get rid of these AND gates or I can replace AND gates with O gates. Okay. So then I can expand because A bar is A, right? I have not done any change. So now I can apply De Morgan rule here to the lower part. A plus C bar plus A bar plus B bar, A bar plus B bar plus A bar plus C bar. Now this is no gate. This is a no gate. Assuming you have the bars and this is a NOR gate and this is a 3 input NOR gate. This is a 3 input NOR gate. So remember I told you that the two rules I will always use is A bar bar is A and the Nimogan. So this time I use the Nimogan in the other way because I want the O gates rather and get it not gates. Right. So now this is an O gate. This is an O gate. This is an O gate and this is a big NO gate. Right. Right. So therefore, now we can create this one using NO gate. NO gate that is AC bar. So this is my A plus C bar. And this is another NO gate. uh, A bar plus B bar. So this is my A, this is my C. Okay. So they say that assume that A bar is available. So therefore I don't need to worry. I don't need to worry to make this A into A bar. Of course I can do it, but I don't need to worry because examiner says assume that. Let's read the question again. uh, Assuming that the complement inputs are also available. So that means you don't need to convert into bar. You can assume that that means you can assume that you have uh, not ABC input. You have the ABC and A bar, B bar, C bar as altogether you have six inputs. So that is just to make our life easy, I hope. Okay, so therefore I'll say this A I will take anyway, and this I will take it as C bar. Sorry, sorry, not C, A. I want A bar. Right? I need A bar. Of course, I can take A and use in NOR gate convert also, but I will just take it because it's examiner says it's available. A bar is available and B is available. B is available. So therefore, this is A bar plus B bar. Now I need A bar plus C bar bar. So A bar is available. Okay. And I can assume that C bar is separately available, because examiner says you have A bar, B bar, C bar separately. So therefore, this is A bar plus C bar bar. Then I need another three input NOR gate. You can assume that there are three input NOR gates because this is X plus Y plus Z bar. Right? You can assume three input in NOR gates. And this is my final output. Is it what is the letter they give? Is it right? Yes. So we'll call it Z there. We'll call this Z rather than writing the big expression. So this is my diagram. This is my diagram. But if the A bar C bar is not available, still I can do it, because if you have something like this, and if this is A bar. Why? A plus A bar is A plus A is A bar. So therefore, if A bar and C bar is not available, still I can take from A, I can create A bar by sending through O gate, NO gate. C bar also I can create by sending C like this and giving the two input as the same input. But I don't do it because examiner says A bar and C bar, all the bars are also available. So this is my diagram. Let's see whether examiner's answer is this. Right, you can see three inputs, no gates. This is for the first answer. I did for the second answer, right? Because I did second answer. Okay. So this is A and C, A and C. Right. So that is A and C. Then I have the A bar and B, A bar and B. So you can see examiner has taken this bar by examiner has made it bar. That is unfair, right? Examiner has told us that A bar, B bar, C bar is separately available. But now this is, you can see this is basically A bar and C bar. This is A bar, C bar. Of course, I took A bar, C bar separately. Right? I took A bar, C bar separately. But examiner has converted A into A bar, C into C bar. So then of course A bar plus B. Right? A bar plus B bar. Right? So this is A bar. Uh, So this is your A, therefore this is A bar, and this is your B. Right. So that is unfair. If examiner has given marks to these no gates, that is very unfair because examiner has told that these are separately available. Let's see whether examiner has put up a note there. Okay. Right. If the wire connections are not clearly indicated, blah, blah, blah. Okay, that is correct. ESET term is not compulsory. That means if ESET is missing, still examiner has given marks, but I put up ESET. Complemented inputs can be input using no gates in the alternative part. Similarly, complements inputs can be obtained directly in the right. You can see you can take the complementary inputs directly because examiner has mentioned that. You can see there's a note here, right? So either you can take the complement using no gate. That is you complement your A into A bar. That is you give A here and give it something like this and take it A bar. Or you can directly assume that the complementary input is there. Okay, you can see. Uh, so that is because examiner has mentioned that complementary inputs are available, right? So that is fair. So that means I should get full marks again. Okay, I should get full marks. So that means either you get create your no gates, create your negations, or you just assume that this is your A bar, this is C bar, and so on, rather than using gate because examiner has mentioned that these are available, right? Assuming that the complemented inputs A bar, B bar, C bar is also available. So that means, right. So both the approaches examiner has given marks. Okay, right. But in the future, you better, even though examiner says like that, you just convert your A into A bar using this. Okay. So any questions? Any questions? So we have discussed this under logic gates. Okay. Logic gates. Where is your right? Universal gates. What are the two universal gates? NAND gates, no gates. From NAND gates, you can get any other gate. NOT gate, AND gate, OR gate, XOR gates. Similarly, using no gates also, this is how you create the NOT gate. NOT gate. This is how you create OR gate because no gate and then not it. Not no is O. And this is how you create AND gate. Right? You better because in the exam in the maybe in your exam, the examiner might ask you to draw the full circuit. Maybe you still having AND gates. So if you have AND gates, you can't get rid of AND gates. So this is how you create your AND gate using no gates. I don't think that the examiner will give you anything related to XO gates because it's too complicated. But definitely, you must remember how to create a NOT gate, OR gate, and AND gate using NOR gates, and how to create a NOT gate, AND gate, and OR gate using NAND gates. Okay, NAND gates. Most of the time, examiners ask about NAND gates, but you can see that 2023 examiners asked about NOR gates. Okay, right, right. B part. Using Boolean algebra, show that this is equivalent to this. So this is my favorite simplification. Okay. Uh, right. So let's take this A bar C plus A bar B, A bar C plus A bar B, A B bar C plus B C. So you need to prove that this is equal to C plus A bar B. So you can just start from wherever you feel like comfortable. But have a look at it, right? You can see A bar B is in the answer. So therefore, I don't want to touch it. Unless I have very good reason, I don't want to touch it because I want to keep it in the answer, right? So then where should I start? I want to keep C also. C is everywhere. Okay, C is everywhere there. Yeah, because C is everywhere, I will take C maybe. Okay, so if I take C out, uh, C, yeah, if I take C out, A bar, I will take this last, then A B bar plus, I took C out, B plus this A bar B. Okay, I want to keep A bar B because I want to simplify this to C. So that means I want to make sure that this is 1, right? This is 1. Okay, so what can I write? This is like x plus x bar y. Remember, this is if you take A bar as x, then it is x plus, this is A is then x bar because A bar bar, x bar, let's say B bar is my y. So remember x plus xy is x. X plus x bar y is x plus y. Remember? A plus AB, one of our 23 rules. A plus AB is A. A plus A bar B is A plus B. So therefore, this is like x plus x bar y is x plus y. But my x is A bar, y is B bar. So therefore, this is A bar plus B bar. A bar plus. You must write the rules, right, in that same line. Okay. You must write the rules in the same line. So therefore, this is my x is A bar. And then A bar bar is your A and Y is my B bar because the answer is X plus Y plus B plus A bar B. Now B plus B bar is 1. Remember, A plus A bar is 1 because either this is true or this is true. When this is true, this is true. When this is false, this is true. True or false is also true. So therefore, this is 1. So C dot A bar plus 1 plus A bar B. And 1 plus something in all logic, when something is always true, final result is always true or 1 because true or something is true. Even true or false is true. True or true is true. So therefore 1 plus something is always 1. Okay. So therefore this is 1 or true. C dot 1 plus A bar B. And something dot 1. Right. Remember A dot 1 is A. Right. A dot 1 is A. Because when this is true or 1, 1 dot 1 is 1. When this is 0, 0 dot 1 is 0. Or true and true is true, false and true is false. So whatever this value is this value. So therefore A dot 1 is A. And therefore C dot 1 is C. So you need to write, okay, A dot 1 is A. Don't use A and B. Just write, use X and Y. Or you write the rule name of the rule. Or you can simply say x plus x dot 1 is x because our question has a, b, don't use a, b. Here I use a plus 1 is, or x plus 1 is 1, right? X plus 1 is 1. Here I use x plus x bar is 1. X plus x bar is 1. Here I use a dot b plus c is a dot b plus a dot c. So likewise, you need to explain. Here I use a plus b is b plus c. That is why I took it there. And you need to write those rules. Otherwise, you will get less marks. Right? So this is one approach. If you do it using other approach, as long as you apply only correct rules, and you have written your rules, you should get the full marks. Okay. Right. So let's see how the examiner has done it. Maybe examiner has done it in maybe one or two ways. Right. You can see examiner has taken C out. Then then A bar plus AB bar is uh, this is X plus X. I don't know how that examiner has taken this. This B is still there. Examiners write this as A bar plus A. How can you write A bar plus A? You can say rules are not compulsory. In that tier, examiner has mentioned that rules are not compulsory. Examiner has not given marks, but you always write the rules. You always write the rules, right? Because all the other previous papers, examiner has mentioned without rules, don't give marks or reduce marks. You better write down rules, okay? Anyway, how does the examiner got this as A bar plus C? We also got A bar plus C, but after simplifying, right? Which rules examiner has used? This is A bar. This is like X plus X bar Y. X plus X bar Y is X plus Y. That is A bar plus B bar. Okay. Maybe examiner has written for this one then. Yeah, examiner has not taken these two because this A bar is coming from this one. Examiner has taken this one. So this is B plus B bar A. B plus B bar A is B plus A. B plus A is same as A plus B. You can see examiner has taken these two. I took these two. Anyway, both are correct. So B plus B bar A, you can see B plus B bar A. That is like X plus X bar Y is X plus Y or B plus A. B plus A is same as A plus B. And now you can take these two, A bar plus A plus A bar is 1. Then 1 plus B is 1. So then C dot 1 is C. Right. So examiner has not expected the rules, but you must write your rules because next time examiner will say without rules reduce marks. Okay. Right. Is it clear? So I gave you the 23 rules, and in the very that day I told you without remembering 23 rules, don't go to the exams. No point. Right? No point. Don't do jokes. Be serious or don't go to the exams. Right. So these are the 23 rules. So we use how many use we use? So we use A dot 1 is A plus 1 is 1, A plus A bar B is A plus B. So we use all these rules. And also we use A dot B same as B dot A. We use A dot B plus C is A dot B plus A dot C. I think we use about 6, 7 rules. So you must remember these 23 rules because though it's 23, it's only about 12 rules because when one rule is correct, its dual is correct. Okay. So these are all dual rules. So you must remember this. Of course, if you like logic, you will naturally remember without any effort. Right. So let's move on to our next subtopic part. So you can see it's a huge question, right? Huge question. Consider the flip-flop circuit shown on the right. This is a flip-flop. So this is a SR flip-flop. You can say R. Remember Q side is R. Right. So don't ever think that Q side is S. No. Q side is R. Q dash side is S. Okay. That is how the SR flip-flop work. So then you must know the truth table. Right. SR. What happens when 0, 0, 0, say 0, 1, 0, sorry, 1, 0 is the set. Set. That is why we said set reset. So this is Q is 1, Q dash is 0. That is set. That is why S is 1 set. Then R1 means reset. That is Q is 0, Q dash is 1. Then 0, 0 is memory. That is memory. Or Qt plus 1 is Qt, memory. And 1, 1 is invalid scenario. So that you should not set because it results in both 1 or both 0. Right. So you need to remember this. Assume that S input is 1, S input is 1, and R input is 0. That means set. What will be the output of Q? Then output of Q is 1, Q dash is 0 because this is set. Right? So the answer is Q is 1 because this is set scenario. Right? You can see these are the rules they have used previously. Right? Answer is output is 1 because it's set. Set. Next one, what will be the output Q if S input is now made 0? Now S input is made 0, right? Now earlier, now read this, right? Earlier it is 1, 0. After 1, 0, now you make it 0. So make it 0 means from here you take it to here. That is memory. Memory. So therefore, whatever the previous input, output will remain there. So therefore, now again Q is 1 because it's memory now. Because memory depends on the previous output. Of course, previous output is 1. That is why they say now. So now again Q is 1 because this is memory. Right? Because Q is uh, now S input is made to 0. R is anyway 0. So that means memory. So therefore Q is still 1. Q is 1, Q dash is 0. You see, still it is 1. Okay, because this is memory. Then what will be the output at Q when R input is now made 1? Now what will they do? Now currently we are in 0, 0 situation. Now you make it R input to 1. R input to 1 means now S is still 0 and R is 1. So that is S0, R is 1 is reset. So reset means now Q is 0, R Q dash is 1. So what they ask is Q, now Q is 0. Now Q is 0. So easy marks. Do you have any questions about this? Because your task is get it clarified things, okay? So this paper is very advanced paper. So this is not a joke. A-level ICT used to be a joke about 3 years ago, but it's no longer a joke. This is very serious as maths, chemistry, physics now. You know that some A-level subjects are joke, right? මාස 3නුත් A-level කරනවා සමහරව. මාස 6න් A-level. Right? A-level in 6 months. So that means it's a joke, right? So some people do A level in a serious manner, some people do it in a joke as a joke. So there are such joke subjects, but not ICT. Right. Any questions? So you can play with this using logically. So of course, if you have done all these things only, you can do this, right? You have played with logically. Right? So you can have two toggle switches. Then you can have two NOR gates. You can use NOR gates or NAND gates. So this is connected to this. This is connected to this. Can have two bulbs. Just to see whether 1 or 0. This is connected to here. This is connected to here. Let's add some labels. This is my R. This is my S. This is my Q, and this is my Q dash. Q dash. Q dash. Now, when S is 1, R is 0, it is set. Yes, set Q is 1. Right? And if I make both 0 now, it remember, right? Now I make it both 0, still it is 1. That is called memory. That is called memory. So if I want to reset, make R1 is 0. Now reset. Now if you want to make it memory, again keep both 0, still it remember. That is how SR latch works. At any time you can set it and remember. At any time you can reset and remember. But don't make it both 1. Right? Don't make it both 1, because if you make both 1, both are 0. That is invalid, right? So Q and Q dash must be different. So that is why we say 1, 1 is invalid scenario. Okay, 1, 1 is invalid scenario. So then you must be able to explain why. I explain why it is so, right? In order to explain this, you need to remember the truth table of NOR gates. Because otherwise you need to memorize like a donkey. So donkeys, like people, memorize things they don't understand. So what is the truth table of B, A plus B bar? 0, 0, 0 plus 0 is 0, 0 bar is 1. 0, 1, 0 plus 1 is 1, 1 bar is 0. 1, 0, 1 plus 0 is 1, 1 bar is 0. 1, 1, 1, 1 plus 1, oh, true or true is true, true, not true is false. Right, now what happens with S1? That is set, right? S1, R0. S1, R0. Now, how do you explain this output? Now, now you can see that uh, when both are 0 only, 1. Right? When both are 0 only, 1. But here both are 0. So this is 0. Right? So remember, this is 0. This is 1. Right? We have set it. This is 0. Okay. Now, when at least one value is 1, output is 0. When at least one input is 1, output is 0. So here when at least one input is 1. But if one input is 0, you can't look at tell the output, because when this is 0, if the other one is 0, it is 1. If the other one is 1, it is 0. So therefore, I can't predict anything about this, because when this is 0, it is 1. When this is 1, it is 0. So therefore, I can't tell anything about this. But definitely I can tell it about this, because when at least one input is 0, definitely output is 0. Yes, this is 1. So therefore, this is 0. Now for the next clock cycle, this is 0. So then both are 0 means 1. And this one comes here. When both are 1, it is 0. That 0 goes there. When both are 0, it is 1. That one comes here. When both are 1, it is 0. So you can see it is set. Set. But you don't keep like this. We set it and take it back to 0, 0. We take it back to 0, 0. Okay. So now our situation is like this. Now what we do? We make it 0, because 0 is your memory. Okay. So then what happens? We make it 0. So when you make it 0, remember previous clock cycle, this is 1 and 0. So therefore this is 1, this is 0. But now we have made both 0. Both 0. Right. Now what happens? We know that when at least one value is 1, output is 0. So here 1, because in the previous clock cycle it was 1. So therefore this is 0. And that 0 goes there. When both are 0, it is 1. And that one comes here. When at least one is 1, it is 0. And you can see still it remain Q1, Q dash 0. So that is how you explain memory. Memory. So similarly, you should be able to explain what happens when you reset. Reset means R1 is 0. So then what happens? Now this is 1, this is 1, this is 0. When at least one input is 1, output is 0. So therefore this is 0. Still I can't tell anything, but in the next clock cycle, this is 0. Both are 0 means 1. That one goes there. 1, 1 means 0. That 0 comes here. 0, 0 means 1. Now it is this Q dash 1, Q 0. But you don't keep this forever. You again make both 0. Still it remain like that. Why is it remaining like that? Because just before we do this, remember this is 0, this is 1. But now we made this also 0. This also 0. But when we do this, previous clock cycle, this is 0, this is 1. Okay, so therefore this one comes here. This one comes here. And this 0 goes there. Right? And we know that when both are 0, because earlier this was 0. When both are 0, it is 1. And that one goes there. Both 1 means 0. So you can see still it keep like that. And this one goes there. Both 1 means 0. And this 0 goes there. Because anyway, this is 0 now. This is also 0 now. Okay. This is also 0. Now this one goes there. Right. So you can see 0, 1 is 0. That 0 comes here. 0, 0 means 1. 0, 1. 0, 1 is 0. Right? So it is like that. And why do we say that don't make both 1? Why do we say don't make both 1? That is, this is 1, this is 1. And we know that when at least one input is 1, output is 0. So therefore this is 0. And when at least one input is 1, output is 0. Therefore this is 0. Then this 0 goes there, this 0 goes there. 1, 0 is 0. Again 0, 1 is also 0. So therefore both remain 0 now. So both remain 0 for the next clock cycles. That is bad. That is both Q and Q dash is 0. So therefore don't make both 1. Because when you make both 1, you get both 0. So you should be able to explain it. Of course, in the exam, they don't ask you to explain it. But if you don't understand this, you memorize like a donkey. It's very stressful thing, right? Memorizing things you don't understand. That is why I told you in the very first day when we start A-level ICT, rely on your understanding. Right? Don't memorize things you don't understand. It doesn't work. Okay. Right. So let's move on to our next question. Right. So that's it. Question 5. So if you know your subject, you can get the full marks. And this is very tough question. Very, very, very tough question. The examiner check whether you know, right, your subject. Right. Now we are into the question number 6. It's a network question. Draw a sketch to show a file server, printer, switch, and two computers, C1 and C2, use exact labels, should be connected in a star topology. That is a super simple question, right? So you must know that you are connecting it to switch. Right? So let's call this switch. Just mark it switch also better. And also label it as S. Right? So then you have the file server and two components. So file server you can connect like this. FS. Then the two computers. You can call them C1 and C2. And printer you can connect to one of the machine or you can directly connect it to switch. Because you have the switch, we can even connect it to the printers. You can connect it to the switch also because printer has its own MAC address and so on. Right? So I'll connect printer. Say this is my printer. Make sure you give the label. So I'll connect it to switch. So I have the two machines and file service also computer and the printer, four things connected to the switch. Or you can connect printer into one of the machine, but don't connect it to the file server, right? Because file server, you better keep it dedicated for that. Right. Any questions? Let's see the examiner's answer also. Right. Examiner has connected printer also to the switch, then the two machines and the file server. If the printer is connected to the computer, give marks. You can see if the printer is connected to one of the computers, still give marks. So that is also correct. But better thing is just connect your printer also to switch. Don't worry. Printers have MAC addresses. Okay. Right. So any questions? B part. The port number is also used along with IP addresses in a network communication. Why? Can someone give me the answer? Can someone give me the answer? Because you guys are going for the exams in 2, 3 months. I think your exams are in November, right? Can anyone tell me quickly? A port number is also used along with IP addresses in a network communication. Why? What is your A level? If you go to the A level exam, what is your answer? Just tell me or put it into chat. If you want to pass your exams, right, you must have the answers because we discussed this. Port number. What is the purpose of port number? Remember, port number has two meanings. So the switches and routers also have port. That is physical port. Here we are not talking about that. Here we're talking about the port number as a logical concept. Remember, a network layer we have IP address. Logical link layer we have MAC address. Network layer IP address. Then transport layer we have the port number. Port number. Transport layer is the one that manage sessions. Sorry, connections. So when your data packet reach the destination, so data packet can reach the destination because your data packet has a destination IP address. Routers will look at the IP address, destination IP address and route it towards the destination. Now the data packet has reached the destination machine because of the IP address, and routers have routed towards the to the destination machine. Now the destination machines always get the data packet. Now the OS need to decide to which application should I give this data packet because that machine may be running so many applications. So that is where the port number is. For example, if the port number of the data packet says 80, and if this machine is running a web server, that data packet is given to the web server. So likewise, there are well-known port numbers. Right? If the port number is corresponding to, say, SMTP, then it will be given to the web server, email server, and so on. So therefore, port number is IP address is used to identify the destination machine, whereas port number is used to identify the running application or the relevant running process or the running application in the destination machine. For example, 80 is used as the port number for web servers. Likewise, you need to explain. So make sure you get the full marks, right? Full marks. Because it says write an example. Uh, you can see, you can take IP address as a reference. Okay. You can explain with respect to the IP address. IP address do this, whereas port number do that. That is how you explain. IP address is used to identify the destination machine, whereas port number is used to identify the this running process or the program in the destination machine. For example, 80 is for typically for web servers. Right, so let's see the answer. Right? It identifies the process that is relevant to the connection. You can see it's very important. Identify the process in the destination machine. Right? Because every process, running process, if it is related to data, or if it is related to network activity, it is given a port number. For example, remember we use SAM server for the web development. Now this is the time you that check your personality, right? So remember you started your A level about 2 years ago, right? Just remember it, okay? Now listen to me. So you start after your O level about more than 1 years ago. You started your A level, right? Some students were very serious from the day one. Some students were relaxed. You don't feel about your A level much until you come to the say second year. Now we are into the half of the second year also. This is where your character is tested. But now you can't build your character. You should have built your character here. So now lot of three subjects, lot of topics, web development, PHP, HTML, CSS, networking, logic, right? Operating systems. Of course, this is one subject. Similarly, you may be doing some serious subject like business management, right? Maybe math subjects. So now your character is tested. So if you have relied on your understanding, now you are very comfortable. Right? You understand concepts, right? But if you just blindly start memorizing things without understanding, so now you are in deep trouble. Now you are getting stressed more and more. It's unfortunate, right? Reality is reality. So, so the how do you manage it? You understand the topics. So that is why I told you that do something you really like. Then there's no stress. So I hope you guys really like your ICT subject. So you like your logic, you like programming, you like working with computers. So then you understand because you like it. So then you look at the exam as a challenge. So if you like facing challenges, so that is even better. Okay. And always interrelate everything, right? So remember when we start web server, so it says port number. Look at this. Okay. It says port number 80, that is HTTP. Port number 440, that is HTTPS. When I start MySQL, because some other machine can connect to my database, my MySQL start in port number 3306, right? For example, my Microsoft Word doesn't need a port number because no one is connect and giving me data to my Microsoft Word. My calculator doesn't need a port number. My PDF doesn't need a port number, but email server, web server, file server, right? My Zoom need a port number. Okay. For example, when a data packet reach your machine, that is related to my voice or my screen sharing. So that data packet must be given to the Zoom running in your machine. So how does your OS know that that data packet must be given to the Zoom? Because Zoom also has a port number. Okay. Right. Right. Next one. Consider the sorry, C part. Consider the subnet. Let me erase this. Right. Consider the subnet with network address 192.168.56.128/26. Right. Write an example IP address that can be assigned to a host attached to the subnet in dotted decimal notation. So dotted decimal notation is this. Then look at the full answer because you can plan out full question. Write the first and last usable host address. Usable host address. Okay. Usable means you can't use the first one because it's a net ID. You can't use the last one because it is a subnet ID. So what you need is the usable addresses. Okay. in dotted decimal notation, how many host addresses are available for the in this subnet? So those are the three. Okay. So that is a super easy question, right? Right. So this is 192.168. Right. 19. Okay, let me take different color. 192.168.56. This is 26. 26 is 888. Then 2 and 6. 24, 26. That means I will write this because this division is in the fourth octet because it's 26 bigger than 24. So therefore, I'll convert 128 into binary. Okay. 128 into binary. 128. 64. Nothing. 32. Nothing. 16. Nothing. 8. Nothing. 4. Nothing. 2. Nothing. 1. Nothing. 0. 1. 1 and 1, 2, 3, 4, 5, 6, 7. 1 and 7 zeros. 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. So that is the IP address. Okay. So that is the IP address or the IP address range. So this is where it is separated. 26. 8882456/26 CIDR notation. Right. So therefore, you can always write an IP address, right, at any time. But let's first find the range. So the first one is all zero. Last one is all one. Actually, this is the first one because all zero. So this is basically the first address. What is the last address? 192.168.56.10 all are one. But remember, this is subnet ID and this is broadcast ID. So these are not usable. Okay, these are not usable. So the question is, I first do this one. First and last usable host address. First usable host address is 10.0.0.0.0.0.1. What is that address? Because this is 128. So then 128 is this plus 1, 129. So the first usable address is 192.168.56.129. So then the last usable address, that is not this. Last usable address is 10.11.11.10. That means this less than 1. So what is this? Because this is easy to calculate. 1, 2, 4, 8, 1, 2, 4, 8, 16, 32, 64 minus 1, 63. 63, but here we have 1. This 1 is 128. So therefore, 8 plus 3, 11, 991. But that is 191 is this one. So what is the usable last address? 190. 192.168.56.190 because broadcast address is 191. So therefore, write an example IP address, anything between these, anything including this. It can be 129, 130, 140, up to 109 because all those are usable. So here, any number like this, okay? That is anything like this or anything in between. But the usable address range is 129 to 190. Okay. How many host addresses? Not how many IP addresses, host addresses. There's a usable addresses. So number of usable addresses is if you have 6 bits to play around, it is 2 to the power 6. But remember minus 2 because the first one and last one you can't use. That is 2, 4, 8, 16, 32, 64 minus 2, 62. Usable number of addresses is 62. So this is an address, answer, this is an answer, and anything, these two or anything between is answer for this one. Okay, right. So let's look at the answers. I'll look at it from below. Yes, 62. Okay. If 61 is written, must what happened to other one? Okay, I don't know what is that. Anyway, answer must be 62. First address is 129 to 190. Yes, 129 to 190. Usable address range. This can be anything between 129 to 190. Okay. Right. You can see anything between 129 to 190, both inclusive. Example is like 138. Even if someone write this, he or she should get marks. Someone write this, he or she should get marks, or anything between like 130, 131, 189, or 190 or 129, but not anything outside this. Right. Do you have any question about that? Do you have any question up to this point about this network question? Right. No, no issue. Everything is clear. You are very comfortable with submitting. Because if you can do one question, you can do any question, right? Right. So this is our second D part. Suppose the internet service provider owns 192.168.56.32. That is different question. Okay. 192.168.56. This is 56. This is 128, but this is 32. This is a separate question, independent question. Suppose the internet service provider owns this particular IP address block. Assume that the provider wants to create four subnets, namely subnet A, B, and C. So he want the ISP provider, internet service provider, want to break it into four subnets: A, B, C, and D. Okay. From this address block, with each subnet having the same number of IP addresses. So this is super easy. Super easy if you know the theory, right? Right. So remember 26 is fourth octet. So therefore we need to play with the last octet. Okay. So that is 192.168.56. So let's say 32 converted it to binary. 16 nothing. 8 nothing. 4 nothing. 2 nothing. 1 nothing. 0 1. 1 and 1 2 3 4 5. 4 5. Then you need to insert zeros to the beginning, right? So insert 0 to the beginning because it must be 8 bits. 1 2 3 4 5 6 means 7 8. 0 0 1 0 and 4 zeros. Remember, you must write it as 8 bits. Right? So this is 32. 1 2 4 8 16 32, correct. Now 26/26, that means 8 8 8 24, 2 more. 2 more bits. This is where the separation start. Right? So this block key is available to you or ISP provider. But from this block, you can create one big network. One big network. But rather than creating one big network, what they want to do is create four subnetwork. So therefore, you need to borrow bits from this side. From this side. How many bits you would need to borrow? You need to borrow, if you borrow one bit, it can be 0 or 1. So that means two subnetwork. But you need to create four subnetworks. So therefore, you need to borrow 2 bits. 2 bits. Okay. Is it clear? Right. Right. Write the subnet mask of the above given IP address block in dotted decimal notation. Now you need to write subnet mask of the given IP address block, this one, in dotted decimal notation. 26 means what? This. That is 255.255.255. Anyway, this question you can straight away write without looking at anything, right? That is easy marks. No subnetting, just write this as a dotted decimal notation, right? So therefore 26 means 255, 255, 255, right? That is 24. Then another 1 1 and 6 zeros, because these are all ones. Or 8 ones, 8 ones, 8 ones. So then 2 1s and 6 zeros, because 26. 2 1s and 6 zeros. What is this number? 1, 2, 4, 8, 16, 32, 64. And the next one is 128. That is 12, 192. So subnet mask for this particular block is subnet mask, right? Subnet mask. For this particular block keys or the other notation, we write it as 255, 255. This is not after breaking it to small parts, right? This is still we are in the fresh question. 255, 255, 255, 192. That is D, right? Yeah, D. Yeah, 255, 255, 255, 192. Right, 192. Because slash 26 means 8 ones, 8 ones, 8 ones, then 2 1s and 6 zeros. 2 1s and 6 zeros is 192. Is it clear? And second one, write the number of host bits needed to create the required number of subnets, because we need 4 subnets. You need to borrow. This is the host part. Right? This is the net part. You need to borrow 2 from the host part. Originally, we have 6 because 26. 32 minus 26, we have 6. But out of these 6, that is why we say borrow from the host side. You need to borrow 2 bits. Right? Number of host bits need to create the required number of subnets. You need to borrow 2 host bits. Right? 2 host bits. Maybe you can write a small description also. That is okay. Right? Just write a small description, but it's not a must. Once the subnetting is done, fill in the following table. Now, after doing the subnetting, what is this? Okay. So first usable IP, last usable IP, network address, broadcast address. Of course, these things can be mixed, right? So A can be B, B can be C, because any range can be assigned to anything, but your answer must be correct. Right. So let's do. Right. So the first one, we can take this as 0, 0. Right. 0, 0. But this is 1, 0, right? Yeah, this is one of the IP address there. Okay. 32. 1, 2, 4, 8. 1, 2, 4, 8, 16, 32, 64, 128. Yes. Yeah. So we forget about this 1, 0. So then 0, 0, 0, 0 is first block. Then 0, 0, 1, 0 is second block. 0, 0, 1. 0, 1 is another block. 0, 0, 1, 1 is another block. Okay. So let's write the first block. 0, 0, this is first block. Oh, I'm going to give it to A, or you can give it to A or B or C or D, it doesn't matter. But let's say I'm giving it to 0, first block. That is 0, 0, 0, 0, 0, 0, 0, 0. Uh, my last address will be 0, 0, 0, 0, 1, 1, 1, 1. Okay. So then it will be 192. I will write it. Okay. Network address is all zeros. This is also 0. Next one I will take it as 0, 1. 192 168 56 56 0. Okay. So the broadcast address will be this address 192.168.56. What about this? 1, 2, 1, 2, 4, 8, 16, 16 minus 1, 50. So the first usable address will be then 1, that is 000001, 192.168.56.1. Last usable address will be 40, that is 1110. Okay. 192.168.56.40. Right. So I took it 0, 0 pattern. Now I will take 0, 1. Of course, this can be assigned to A or B or C or D, right? It doesn't matter. Okay. So next I will take the next bit pattern. Okay. Next bit pattern. That is 0001. 0001. Then 0000 is my first address. 0001. 1111 is my last address. That will be 192.168.56, 1, 2, 4, 8, 60. Anyway, it is one bigger than this. The last address or broadcast address is 1248. Yeah. 1248, 1248, 16, 32 minus 1, 31. 31. 192.168.56.31. Then this is 192.168.56.17 to 192.168.56.30. Okay. So the next one I can take 10, and the last one I can take 11. Okay. 0010, 0000. Last one 0010, 1111. What is this? 1248, 16, 32. Obviously, it must be one bigger than this. 192.168.56.32. Last one is 1248.16.32 plus 1248.16 minus 150. 47. 192.168.56. So the range is usable range 192.168.56.33, 192.168.56.46. And the last one is 11. Right, last one is 11. Because those are the 4-bit patterns available, right? So then this is 192.168.56. This basically 48. 1248, 16, 32, 32 plus 60, 32 plus 16, 48. The last one is this is 48. Okay, then this is 1, 2, this is basically 1, 2, 4, 8, 16, 32, 64 minus 1, 63. 63. And the usable addresses will be dot 49. These are the same. Dot 62. So anything, this can go to anywhere, right? These things can be set because IP address range we can give to any network because these are the same size. But these are the ranges. Okay, so this double check. Say 0 to 15. Right, 0 to 15. And this is 1 to 14. Then 16 to 31. Yes, 16 to 31. Then 32 to 47. Right, 32 to 47. Last one 48 to 63. 48 to 63. And here it is 49 to 62. Correct. Okay. right? So far I'm 100%, right? I should get 100%, right? You go there to get an A, right? You don't go there to get anything lesser than A. Because if you know your subject, why do you want to get anything lesser than A? Not A, good A, 90 plus. But you have a task. If you have any doubt about any subtopic, send me a message, talk to me, or send it to your WhatsApp group, right? I can help you anytime. Right? I can help you anytime. So I really help those who want to study, those who are genuine students, right? Those who want to understand things, right? E. Write two functions of proxy servers in a computer network. Remember, proxy server is examiner's favorite device, right? ඒ කියන්නේ proxy server ගැන ප්‍රශ්නයක් ඇහුවේ නැත්නම් examiner නින්ද යන්නේ නැහැ. Right? Almost every year there's a question on proxy server, right? So what are the purposes of proxy servers? Remember, what are the devices? Switch. Switch your data frames to the correct machine. Hub. Broadcast all the incoming data frames to all the other outgoing ports. Broadcast. It's a dumb device. Physical layer device. Switch is layer 2. Logical link layer device. So that is why it can switch the data frame to the correct machine because it has the MAC table. Then router. Router can look at the destination IP address of your data packet and route it towards the destination, not to the destination, towards. Okay, the best path, best route. Okay. So then we have the firewall. Firewall is security device. Analyze incoming data packet and block any possible virus, those attacks, hacking attempts, and also it can analyze the outgoing traffic and block if your internal employees try to access something like porn sites or anything that they are not supposed to access in their working hours, or if they are trying to do any illegal sort of a thing. Analyzing incoming data packet and block for the security. Analyzing outgoing data packets and block for proper administration. Prevent misuse of your network. Right. So another device is proxy server. Right, proxy server. So I'm doing a bit of revision also. So proxy server can do multiple things. Multiple things. Proxy server can cache some web pages which your users frequently access so that you don't take it from the server. Right? Proxy server can do the network address translation, private address to public IP address. Okay. So those are all activities of a proxy server. And also proxy server can analyze data traffic like a bit of a firewall, bit of a security task. So proxy server is a sort of a versatile device. Okay, versatile device. It can cache, it can do address translation, private to public, right? It can do a bit of security, like the task of the firewall as well, like a mini firewall. Okay, proxy servers. Basically, it can analyze the traffic. Right? It can analyze the traffic, incoming and outgoing, just like the firewall. Right. So let's see what are the examiner's answers. Right. Acting as an intermediary between the user's computer and internet. Right. Intermediary. So that is like a security guard. Okay. Offering access to uncensored internet, allowing client computers to make indirect network connections to other network services, helping users to browse their web anonymously. Right. Proxy server can act like a VPN server also, providing high level of privacy, right? Hiding actual IP address, that is called IP address translation. Right? So those are all right? So examiner has given tons of answers. You just need to write only two. Okay, some more. Storing recently requested web object, that is called caching, right? Caching. You can see caching. So that will speed up. So the users will feel like they are getting the page fast. Actually, they are getting the page from the proxy server. Proxy server has cached some frequently visited pages. Hiding network from outside, thus securing the network. That is private to public IP address. Your actual IP address is hidden. Forwarding web requests, content filtering. So remember, we can filter out saying that, okay, no, you are not supposed to go to the YouTube, this office network. You are not supposed to go to that kind of a website, inappropriate website. And also, I told you that it is acting like a mini firewall, security device. Actually, these things are, most of these are actions of a firewall. So it's like a mini firewall. Okay. And of course, in helping control the internet usage, blocking your internal users going to unnecessary or not relevant sites, not relevant servers. So this is right examiner's favorite question, right? So therefore, make sure you have write your best answers like caching, IP address translation, analyzing traffic can provide basic security. So those are the best answers. Usually, examiner will not ask you to write five. Maybe examiner will ask two or three usages. Okay, two or three usages. Right. Last one. Write two properties of MAC addresses assigned to a device connected to a network. Now, this is little bit open question, right? Write two properties of MAC addresses. This is open question, right? So now you need to think and write. And anyway, this is a little bit unfair question also. Properties of MAC addresses. So what comes to your mind? When they ask two properties, I will write at least five properties because this is very open question. Right? Very open question. Assuming that out of my five or four answers, two of those are in examiner's list. Okay. For me, first property is MAC address is hexadecimal number. Hexadecimal number. Okay. How many parts are there in hexadecimal number? Six or four? I think six, right? I can't remember exactly. I think six.
Blocks.
Six or four?
Six.
Six, yeah. Six parts. The first three is manufacturer's ID. The other three is it's six means something like this. Okay. Yeah. So the second part is like a serial number. So therefore, it sort of uniquely identify your machine in your local area network. So you can say MAC address is a six component hexadecimal number having two parts. First part is manufacturer ID. The second part is the serial number. And also you can write MAC address uniquely identify a device in the local area network. So the last, my main point is the last one. MAC address, property of MAC address is it can uniquely identify a device in the local area network. And again, I can write MAC address is a layer 2 concept, logical link layer concept. Another property is I can write MAC address is MAC address of the destination and source are included in data frames. Then I can write MAC address is used by switchers for switching data frames to the correct destination. So likewise, I can write so many points about MAC address. At least I will write five. And MAC address is sort of a hardware address or firmware level access which we can't change easily. Okay, right. So let's see what are the examiner's answers. I can see it's 48 bit. 48 bit means 8, 8, 8, 8, 8, 8. 8 into 6. Okay, and 6 groups. Remember, 6 groups of 2 hexadecimal digits. You can see it's a very descriptive answer, right? It explains everything, right? I think the examiner is not expecting everything. Maybe at one of these you mention, you get that one mark. 48 bit, 6 groups, right? 6 group of 2 hexadecimal numbers, something like that. So that is 1 point, right? Not multiple point. All these considered as 1 point. Or if you have just this, it is 1 point. Then they are physical addresses or hardware oriented. Remember, I also had that answer. Right? They are attached to the NIC, network interface card. Your network interface card is there in your machines, laptop, desktops, and even in printers, scanners, and they are assigned by manufacturer, right? We can't change it, like IP address, right? So they cannot be changed. Of course, you can change it, but you need sometimes you can change it using firmware, but usually we don't go do that. And their unique addresses assigned to the interface of your MAC address sharing is not allowed, right? So these are unique for your network, your local area network, right? So then you can use MAC address to uniquely identify a machine, okay? And it operates in data link layer, right? MAC addresses cannot be found easily by third party. Yes. Usually MAC address is not exposed to the third parties. It is an internal thing. Anyway, so we have enough points, right? We have enough points. Right. So seventh question we will skip because still we have not done this topic. Okay. So we will do that after doing that part. Okay. You can see it's a huge question, right? You can see how long that question is. Right. Now we are into the eighth question. So eighth question is Python question. So Python question is difficult question. Actually not difficult. It's a very lengthy question. I don't know why examiner is giving this kind of a lengthy question. Okay. Okay, we'll get back to the Python question after doing database. Okay, database and yeah, we'll take Python question last because it's a very lengthy question. Okay, right. So let's we will do this, but as a last question. Okay, right. Maybe next class because today I want to finish this question because if I start this, I will not be able to finish this. Okay, it's a lengthy question. Right, ninth question. That is the last one. Yes. No, 9 and 10, two questions. Consider the following requirement relevant to databases that is expected to manage divisions, officers, and tasks in office. Right. So pay attention to the words. Divisions, officers, tasks in an office. I don't know what is my officers in office. I'm not very sure. Okay. Officers and tasks, maybe. Yeah, let's read it. The office consists of number of divisions, right? So the question explaining. The office consists of number of divisions. Each division has unique name. The division may have several locations. Okay. Division handles number of tasks. So let's try to put it into a sort of a structure. So we have division. Division has several locations. And one division can have many locations. Locations. Let me try to put it like this. Right. Division has many locations. Division has many locations. Many. Right. One division has many location. I don't know whether one location has many divisions. And division handles number of tasks. So that means division handles many tasks also. Tasks. One division can handle many tasks. Maybe one task belong to one division. For the time being, let's assume like that. But if you want, we can change it. Name which has a unique number, a name, and a date in which the task was assigned to the division. Each officer's names consisting of first name and surname, NIC, address, and phone number is to be stored. So that is officers. I hope officers are connected to a division. Okay. Are these officers, right? Not office, officers. Okay. So maybe division has many officers, but I will call it officer, right? So hopefully one division has many officers. One officer is connected to one division. For the time being, I will assume, but if there are any other information, I will change it. An officer is assigned to one division. Yes, one officer is assigned to one division, but may work on several tasks. Right? Officer can be assigned several tasks. So that means here this is several tasks, many tasks. But I hope one task is for one officer. Okay. Uh, an officer is assigned to one division. Is managed. Sorry. An officer has assigned to one division but may work on several tasks which may not be controlled by the same division. So that means these tasks can be from different divisions also. Okay. So that means officer can be in different divisions also, right? An officer is assigned to one division. An officer is assigned to one division. Yes, officer is assigned to one division but work on several tasks which may not be controlled by same division. That is strange, right? So maybe officer is in one division but he may need to attend to tasks which are outside his division also. Okay, his division also. That is little bit strange, but yeah, that can be the case. You're officially working in say Gamha division, but maybe sometimes you will be assigned task of Colombo division as well. Right? Right. So that is interesting point that maybe we need to pay attention, but may work on several tasks which may not be controlled by same division. Each division is managed by one of its officers, and the starting date in which the officer started managing the division is stored. So that means time to time, different people can manage your division, right? So that is why the starting date is there. Maybe after certain date, another different officer is the uh, manager. Okay. Draw an ER diagram for the application showing the entities, attributes, and relationships. Underline primary keys. So this is a tricky one. If I go to the exams, okay, if I can find some other questions, I will not do this because there are a lot of fussiness somewhere here. Okay, this is not a very straightforward one, but anyway, we'll do it, right? Because by look of it, it is not a very straightforward ER diagram. Okay, some fussiness is there. I hope examiner will give some uh, freedom for that fussiness. Okay, so I'll just copy this. So that I need some space. So it's very important that in the exams, you select the correct questions or the question that best suit for you, right? Best suit for you, right? For example, even though I told you that the programming question is lengthy, I prefer to do that programming question rather than this. Okay, in the exam because this looks maybe I can come up with the exact ER diagram, but I can see there's a fuzziness with my experience. Of course, you must also now have got that bit of experience. Okay, right. So this is the question. Right. So we don't draw analysis ER diagram, right? Not design ER diagram. Analysis ER diagram. Let's try to draw as much as correct as possible. Right. I will start with division. I will start with division. You need to add some important attributes, especially identifiers, right? You can see draw an ER diagram for the application showing entities, attributes, and relationships, underlying primary keys, right? Underlying primary keys. So I hope usually we don't use the word primary key in analysis diagram. So that is another confusion I'm having with this question, right? So usually in analysis, now this is like a design ER. In analysis ER, we use this notation. Okay. But in analysis ER, we use the word identifier, not the primary key. Therefore, I'm a little bit down, but uh, as far as I know, in the history of A-level ICT, always they ask about analysis ER. So therefore, I'll go for analysis ER, right? Analysis ER, not a design ER. But usually we don't use the word primary key in design ER. That is another doubt I'm having, right? Because in the exams, you need to manage risks. Manage risks. Okay, so that is why I told you I'm reluctant to do this question in the exams unless I have any other. If you have any other questions, I will go for that. Okay, but I didn't tell you anything like that for the network question, logic question, right? But this one is a little bit fussy. But anyway, I will go for analysis ER because that is the ER so far they have been asking. Okay, right. So I will go for something like division first. Right, division. I will add attributes later because the major thing is relationships. So then obviously division has many locations. That is not fussy at all. Remember, use singular location, not locations. I draw it neatly, I'm right, not like me. Then division has tasks. Okay, division has tasks. Division consist of location or something like consist. Try to add a verb. Tasks. Singular. Division. What is the word they use? Division handles. Okay, use the word handle. Handle or handles tasks. You need to specify one to one, one to many later. Then division has officer. 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 Like officer manage division. Okay. Right. So now I will again read and try to add more details. Manages divisions, officers, tasks in an office. Okay, right. Officers, division, locations. Yeah. The office consists of number of divisions. Right. Do we need office then? Yeah, we need office, right? So then officer and office. Because they talk about office, they talk about officer also, right? The office consisting of number of divisions. So yeah. So let's go for office also then. I'll make this first office. So then it is not manage. Office. Say consist of divisions. Okay. The office consists of number of divisions. Uh, that means hopefully office has many divisions, number of divisions, and one division belong to one office. Maybe you can first use a pencil and then mark it in a pen, or you first use a rough paper and then transfer it to your actual answer sheet. Okay. Or you can just use your normal paper, but if you feel like it is running out of options, you just write it in a different paper. Okay. So you need to think about those things also, right? This is pretty uh, challenging exam, right? Maybe actually for me, the biggest challenge I faced in my academic career is facing A level. There's no doubt, right? It's not my degree programs or whatever. It is facing A level because at that age, right? At that age, it was a big challenge. But yes, the degree programs, exams are even tougher, but by that time we were also matured. We had that confidence. But A level is sort of a transition period. Still, you are not adults, right? You are just stepping into the adulthood, right? Your brain is still developing, right? Now these days, your brain is developing day by day. Okay. So that is why it is very challenging. So therefore, don't take too many risks also, right? Right. So let's write the office consisting of number of divisions. Okay. Each division has unique names. Okay. Name is unique, it says. So therefore, I'll say name is unique. Right. Name is unique. Maybe name is our primary key or identifier. The division may have several locations. Okay. Division may have several locations. That is one division has many locations. We say one location has one division. Uh, okay. Many locations. A division handles number of tasks, right? One division has many tasks. Let's assume one task is for one division, okay? Many tasks handle number of tasks, each of which has a unique number. So let's say task number, task number. That is your identifier for primary key. A name and date. Name is also there. Date of assignment. Date of assignment. Okay. In which the task was assigned. I just call it date of assignment. Okay. Don't just say date because it doesn't make sense. Uh, each officer's name consisting of first name and surname. So officer has name. It looks like it is a composite. Name. It's a composite. First name, last name. Okay. Last name. What else? NIC. NIC possibly the identifier. Possibly the identifier or the primary key, and address and phone number. Address, phone number, phone number. Assume one phone number because it doesn't say phone numbers. I will not go for multi-valued. I don't know if the examiner go for multi-valued, but I will just stick with one value, assuming that just one number we need because it has not mentioned like that. Okay. An officer is assigned to one division. So one officer is assigned to one division. This is office, right? So sorry. So I have marked it in the wrong place. Officer is assigned to one division. So therefore, this should be office. Okay, I will change this to officer then. Then I will take office separate because I have already. Okay, so no one told me, right? So let's say this is officer because I have already marked the attributes. Officer. So one officer is assigned to one division. So then it is other way. I will mark office separately. One officer is assigned to one division. Obviously, one division can have many officers, right? So this is then assigned, okay? Assign, assign. Uh, office I will take separately then because they don't talk about office anymore, right? An officer is assigned to one division but may work on several tasks. So that means officer can work on several tasks. It looks like we need another connection like this. That officer work on several tasks. Okay. Maybe one task is given to one officer because they have not mentioned anything like that. Okay. Officer is assigned to one division but may work on several tasks which may not be controlled by the same division. That means one task can be assigned to controlled by many divisions. Right. So therefore, I'll go for M to N. I just change it to empty because maybe that task is related to multiple divisions. Okay. And obviously, one officer can work on many tasks. Okay. I don't know whether one task can be handled by many officers also there. Okay. May not be controlled by the same division. Right. It says may not be controlled by the same division. Right. Oh. So then I will just keep it one. Maybe not controlled by same division. Right. But anyway, you need to work outside. Anyway, still, I will keep it one. You can see there's a fussiness here. Anyway, let's see. Each division is managed by one of the officer. So this is again officer and division, right? Officer and division. Uh, but this is different story. This is officer work for a division. And now we need officer manage your division also. So that I will mark it as a different relationship. This is assign and this is manage. Manage. Okay, one officer can manage obviously one division at a time, right? Let's see. You can see a lot of fussiness. Each division is managed by one of its officer and its starting date in which the officer started to manage the division is stored. So the starting date must be here. Attribute for this one. Start date. Because that is not officer's attribute or division's attribute. Right. So this I am not very sure about this multiplicity. Hopefully officer can manage multiple divisions at different time. That is why start date is there. And division can have different officers at different time. So usually when you have attribute here, it is many to many. That is one officer can manage different divisions at different time and one division can have different officers at different time. That is why starting date is there. Okay. Right. Each division is managed by one of its officers and the starting date in which blah 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 correct. Right. Now I'm pretty much done, but then what happened to the office? Maybe office also will do office because it's all the management are division level. But I will have this one also. Office has divisions. One office has many divisions. One division belong to one office. So then try to add maybe locate. You can add one or two attributes, right? Other than mentioned here, maybe location ID, location name, office ID. At least mark identifiers. A task ID we already have. Maybe name is our identifier here. Or additionally, you can have division ID, but it says name is unique. We'll use name. So this is my uh, ER diagram, right? This is my ER diagram. So I hope you guys also has already your ER diagrams ready. Uh, maybe you have a double check also. That is fine. Okay, let's look at the fast answer sheet. We skip two questions for the time being because one we haven't done it yet. Other one I just skip it for the time consumed. Right. So this is the examiner's right. NIC number, primary key. Name is composite, correct. Address, phone number as a single thing. You can see two. Officer works for division. Office is managed by division. So examiner has taken this as 1 1. I thought it is many to many, but examiner has taken it as 1 1. Okay. But this one is correct. Division has many officers. Officer is in one division. And this is division name is primary key. Location, examiner has taken it as attribute. So I took it as that is the main I took location as a entity. Examiner has taken it as attribute, multi-valued attribute. I think it should have been better going for multi-valued attribute. Okay, so I think it's maybe my bit of mistake. Okay, right. I took location as another uh, entity, but actually I feel like yes, location should have been a multi-valued attribute. but then you don't need this location ID and name also, because this should have been done in the design time. So I have done a bit of designing work in the analysis, which is not good. So therefore, yes, I agree with the examiner. So I will lose few marks, just few marks for this one. Maybe just 1 marks, because it should have been something like this location. Because then at the design time, this multi-valued attribute will be converted to a one-to-one relationship. So I have done bit of designing, right, at the analysis time. Maybe that is I'm overthinking. Okay, but other than that, this is examiner has taken it as one-to-one. I took it as many-to-many. So those are the small issues. Maybe I will lose another one mark for this, because I mark it as many-to-many, but I have marked this attribute properly. Okay. So what else? Yeah, these things are other things are okay. Division is connected to division has many tasks. Task is one division, right? Division has many tasks. Yes, task is to one division, correct? Yeah, other things are okay. Only thing is this is one-to-one they have taken, and also this is multi-value. Other things are correct. Okay, other things are correct. Let's see some notes. Suitable attribute names are acceptable. Okay. 3 marks for 3 entities. Okay. I got the 3 entities, office, division, task. Actually, I mark additional one also, but it looks like I'm not going to lose anything. But if the marks are given to this, I lose some marks. Okay. Definitely, they should have given some marks for this. 1 mark for indicating the locations, multi-valued attribute. You can see multi-valued attribute. So that marks I don't get, because I mark it as a relationship, and okay, and it must be connected to the division. 1 mark for the four relationships with the correct, right, correct cardinality. You can see they have checked the cardinality. So again, I will lose one particular mark, because I mark it as many-to-many. Okay, but anyway, still I can feel it like many-to-many, right? Because that is why they have the start date. Because at different times, different people still like defend as many-to-many. But anyway, what to do? Examiner is the final verdict is from the examiner. Uh, okay, 1 mark for all the attributes correctly being listed and connected properties and blah blah. Yeah, so definitely I will lose 2 marks out of this. Okay, 2 marks for this. Out of 5, I will get about, I think, about 8 marks. I will get two less marks. Okay, right. So we will continue with this one in the next class. We will finish this. Then we will finish this. Okay, memory OS question, and then we'll get into the uh, programming question. Okay, and afterwards, if you have time, I will do the new emerging technologies as well, because emerging technologies we can do it in even one day, right? One day or 1.5 day. So then we just have one more topic, IoT. Okay. And we'll continue the past papers, right? After 2023, I will get back to 2022 paper, MCQ, then structured and essay. Okay. Right. We stop at this point. Thank you.
Thank you, sir.